right, welcome to our class for today. So we have moved from simple stresses and strain to shear stress and strain. Now this is question number 1 underneath shear stress and strain. Now the question says calculate the force required to punch a circular blank of 60 mm diameter in a plate of 5 mm thickness, whereby the ultimate shear stress of the plate is 350 Newton per millimeter square. So what are we asked to calculate? The force required to punch a circular blank. So let's calculate this now. Now, first thing first, we are going to be bringing out our parameters. So we can say data given. Now, the first data we have here is 60 mm diameter. That is the diameter of the plate, which is what? 60 mm. So we have D to be equal to what? 60 mm. Next, we have a thickness of what? Of 5 mm. So our T is equal to what? 5 mm. What do we have next? We have an ultimate shear stress of 350 Newton per millimeter square. Of course, we are dealing with shear stress. It will no longer be sigma, but tau. So we have our tau to be equal to what? To be equal to 350 Newton per millimeter square. But don't forget, we are told that this shear stress is ultimate. So we can just represent ultimate here with a little subscript of U. So now let's solve this question. What is the first thing we are going to do? We are going to be looking for the area first. We are going to be looking for the area of this circular blank. Now, of course, to get the area of this circular blank, we know that what if a hole of diameter D is to be punched in a metal plate, because we are being told that this what is it called? This plate is a metal plate. So if a hole of diameter D is to be punched in this metal plate of a thickness T, then the area to be sheared, that is the area that will be sheared, A, will be equal to what? It will be equal to pi D multiplied by T. That is pi multiplied by diameter multiplied by thickness. So we have area to be equal to pi multiplied by diameter multiplied by thickness. So this is the formula we are going to be using to calculate our area. Of course, we know that D is 60 and T, which is our thickness, is 5. So we can substitute and get our area. So we have pi multiplied by 5 multiplied by 60. What do we have? Press your calculator. You realize that the value of our area is, in order to get our area A, we have, of course, you just press this in your calculator and you have your area to be nothing but what? 942.6 millimeter square. So I have 942.6 millimeter square. So this is my area. Now, of course, I can use my area to calculate the force required to punch a circular blank. Of course, I can use my area to do that. How do I do that? We know that shear stress is equal to what? Resisting force all over what? All over cross-sectional area. So tau, which is our stress here, will be equal to what? Will be equal to P all over what? All over A area. So of course, if we make P the subject, it implies that P will be equal to shear stress multiplied by area. Yeah, of course, we have ultimate shear stress multiplied by area. So therefore, P is equal to, our ultimate shear stress is nothing but what? 350 Newton per millimeter square. So we have 350 Newton per millimeter square multiplying our area, which is 942.6 millimeter square. We have 942.6 millimeter square. Of course, we know that our area is in millimeter square. So therefore, if you press this in your calculator, you're going to be having nothing but what? 329.91 times 10 to the power of 3 Newton. Of course, this will be our force required to what? To punch a circular blank. I hope you understand and comprehend this question. Stay tuned for more numericals on simple stress and strain. Thank you for watching.